Great job, students. How are you doing? Who is with you here? It's Zazi Biela from Entertainment, reminding you that if it's the first time you are viewing our page, please make sure that you subscribe to our YouTube channel so that whenever we upload anything here, you can be notified. And please, if we did something and you find yourself struggling with it, please on our comment section make sure that you write the question. If you are satisfied, please recommend us on our comment section so that we become alert that our viewers are satisfied. Okay, here we're still continuing with the calculus, but now we are doing cubic function part, of which the problem that you are faced with today, we are given the sketch below that shows the graph of h at x being equal to x cubed minus 7x squared plus 14x minus 8. Okay, we are given the x coordinate of the point A to be 1, yeah. The x coordinate of a point A is 1, C is another x intercept of h. Okay, so this is a sketch that is given to us. Here's the sketch. We see here that we have A, and we know that A is the x-intercept, and here's another x-intercept, and here's the third x-intercept. We see that B is our turning point, and here we know that x is equal to 1. So meaning, since this one is the x-intercept, meaning the point A can be written as 1 is to 0. Okay, this is just a breakup of the information given to us. There is nothing new. And then from here, let's just rush to the question given to us. Here we are required to determine h prime of x. And you can see that it's just a 1 mark question, meaning there's no much work to do. It's just an easy like 1, 2, 3. Okay, here let's just start by writing the equation given to us of h at x, of which is h at x equivalent to x to the power of 3 minus 7x squared plus 14x plus 8. Okay, let's just run and look whether am I... Yes, not copied correct. It's not plus 8, it should be minus 8. Okay, it's minus 8. And we are required to find h prime of x. So here, h prime of x can be found by doing this. You take an exponent of x, you multiply the coefficient of x, and then you subtract 1 on the exponent of x. Like 1, you say 1 times 3, it becomes 3. It's 3x, and then when you subtract 1 to the exponent of x, you get 2. And then when you have 7, minus 7 as the coefficient of x, you multiply it by 2, you get minus 14. So it becomes minus 14x, and then on the exponent of x, you subtract 1, it becomes 1. So you can leave it like this. And from there to here, you see that this one is just x. You know that any real number has an exponent of 1 divisible by 1 can be multiplied by 1. Meaning you can take x as x to the power of 1. And when you say 1 times 14, you get 14. So it becomes plus 14. And then when you say x, here you have 1. When you say 1 minus 1, you get 0. So any number or any real number to the power of 0 is always equivalent to 1. Okay, so this is h prime of x, that is equal to 3x squared minus 14x plus 14. We are done. There's nothing much to do. It was just a 1 mark question. It was just a 1 mark question. That's how you score your 1 mark. Moving forward, now we can see that okay, marks are going from 1 to 3. Here we are required to determine the x coordinate of the turning point, of which is B. We are not required to find the entire turning point, but it's just an x coordinate of a turning point, of which is B. How do we find the x coordinate of a turning point given a cubic function? We know that x coordinate of a turning point B can be found using what? Using this equation, of which x prime of x being equal to 3x squared, okay, minus 14x plus 14. Okay, someone may wonder, how did I come across that? Okay, whenever you want to find the stationary point are being found by differentiating the given function. If you're working with a cubic function, you have to differentiate it first time. So a first differentiation of a cubic function gives you a stationary point, and the stationary point can be found by differentiating the given function once. Yeah, it's just h prime of x, of which is differentiating first times, first differentiation of the function given of a cubic function. Yeah, you differentiate that one once, and then you find the stationary point. And we know that a gradient of which is denoted by h prime of x at a stationary point is equivalent to 0. So meaning you can rewrite this as 3x squared minus 14x plus 14, you equate it to 0, and then from here you solve for x. Okay, we want to find the factors of 14. When you multiply them, they give you positive 14, but when you add them, they give you minus 14. So how can we find those factors? Bear in mind that this sign here of the constant, because this one is ax squared plus bx plus c, so the sign before c is positive, which tells us that our factors should be with same signs, and the middle term gives us the signs of those factors. So our factors should all be negative, so we should have negative factors. Okay, moving forward, okay, here we see that we can find the factors of the first part by writing. It becomes 3x, okay, 3x and 1, okay, being equal to 0. Okay, here we know the factors. If you multiply the 2, you get this one, but we do not know the rest. Which one can you multiply which one with, and then when you add them you get what? Okay, it's fine. We know the factors of 14. You can say 14 times 1, you get 14. Okay, if you say 7 times 2, you can get 14, meaning these are the factors of 14 that we know. Is there any factor besides this one? I doubt. I don't think we do have. I don't think we do have except this one. Okay, how about we give our factors of 14b, 7 and 2. Okay, if we can write 7 and 2 here, write 7 and 2. This one tells us that signs are the same. They should all be negative. We give negative, negative. But when you say it's 3x multiplied by minus 2, you get minus 6. But when you say minus 7 times this one, you get minus 7. So when you say minus 7 minus 6, you get minus 13, of which is not 14. That means this one is out. You mark it out. Okay, how about I make 14? Let me check 14. Let me check 14. Okay, let me now plug 14 in 1. Let me plug, suppose I write 14 here, I write 1 here. When you say 3x multiplied by minus 1, you get minus 3. When you say minus 14 times this one, you get minus 14. But when you add the 2, because when you say this one times this one, minus 14 times minus 1, you can get 14. But when you say minus 3x minus 14x, you get minus 17x, of which is not equivalent to this one. That means we don't know the factors of this one, because the factors that we know does not give us what we want, meaning we have to go straight to what? We go straight and borrow this equation, of which is a quadratic equation. which is this one, say minus b plus or minus the square root of b squared minus 4ac. You only use this one only if you do not find the factors. You do not find the factors or you don't have factors. So it's 2a. Okay, here the value of a is equal to 3. The value of b is equal to minus 14. And the value of c is equal to what? Is equal to 14. Okay? So let's plug all the values that we know. Where we see b, we plug minus 14. But please make sure that you put that minus 14 on a bracket, since we have a negative sign here. Because if you just plug it as it is, you might end up writing 14. You see? So yeah, please make sure that you put it in brackets. Becomes minus, you plug minus 14. Okay? It becomes plus or minus square root of, we said it's minus 14 squared, because if you decided to write minus 14 squared, we know that minus 14 squared is not equal to minus 14 squared. So please make sure that you always keep this bracket on. Okay, minus 4, where you see a, open bracket, you plug 3, the other one is 14. Okay, you divide by what? Divide by 2a. So our a is 3. Okay, this one is not easy for us to find. I have to borrow the calculator. Let's just use our calculator. Okay, just use our calculator here. Here's our calculator. Okay, here's our calculator. Okay, all right. Open this calculator of ours. We are working with a fraction, so it becomes the minus of minus 14. That's minus 14. We close the bracket. Let's just start by taking plus. Okay, it's plus. And then we put this thing under the square root, open brackets, minus 14. It's minus 14. You square it. Okay. Our calculator is not showing us everything. Okay, minus. So it becomes 4. Multiply by 3. Okay, multiply by 14. Okay, close the bracket. Underneath we have 2, the value of a is 3. Okay, I did not close the brackets here. Okay, here it's become 7 plus root 7 over 3. It's 7 plus root 7 all over 3. Okay, here it was. Okay, so this is the first value of x, or x is equal to, now you go back to the very same. Okay, everything of mine is now deleted, meaning I have to repunch. Yeah, I have to repunch the information. Okay, it's fine. It's fine. We have enough time. It's minus 14, close bracket. Now you don't put my plus, you put minus. Okay, b squared is minus 14. It's minus 14. Okay, you square it, say minus 4, multiply by 3, which is the value of a, and 14 is the value of c. It's all over to the value of a, we know is 3. Okay, right, let us, okay, this one is equal to, okay, 7 minus root 7. So becomes 7 minus root of 7 all over 2, all over 4, all over 3. Sorry. This one is all over 3. That's all over 3. Okay, but we cannot leave it like this. We should write it in decimals. So x is equal to, or x is equal to, okay, I calculated this, okay, okay, here it's 1,4,5, it's 1,45, right? Okay, let's just check the other ones. Let's go back here, I will replace this minus by positive, by plus. So we delete this minus, we put what? We put plus. Okay, okay, and set form is 3.21. So becomes 3.21. Okay. All right. So it's 3.21 and this one. So let us go back to the diagram. Okay, in the diagram, we know that here we have 1 and we now have two values of x. Ne? So meaning the small value of x is the one that will be taken by b, since b is the turning point that comes first before the second one. So meaning this one will take the value of a of x that is equal to 1,45. Yes. So meaning this is the value of x that we take. So yeah, here. So we then say therefore an x TP of b, so is an x turning point, is the x intercept of the turning point of b is equal to 1,45. Yes, becomes 1,45 is to y, because at the moment we don't know the value of y, and they did not ask us to find that value of y, but we were required to find just that value of x. Okay, we are done with that one. Moving to the second one. Here we are required to determine the coordinate. We are required to calculate the coordinate of c. So if they speak of coordinate, that means they want us to find the x value and the y value. All right. Here, c is the x-intercept of a cubic function, but we know that x equal to 1 is one of the factors that makes this one be equal to 0. How does it make it equal to 0? If you can plug 1 here, you will get 0. Let us prove this one. Okay, let's prove it. So here we say 1 to the power of 3. Okay, 1 to the power of 3 minus 7. Replace 1. Okay, plus 14 times 1. Okay, minus 8. Okay, you get 0, meaning x minus 1 is a factor. Okay, in this scenario, we have to do a bit working, but it's nothing complicated or it's nothing impossible. So we know that h at x is equal to x to the power of 3 minus 7x squared plus 14x minus 8. But we know that x is equal to 1 is the factor, meaning we can rewrite this as, if you reverse this thing, this implies that x minus 1 is equal to 0. So that means we can use x minus 1. So here that means x minus 1, okay, here x squared. What I don't know is the middle term, so I can replace the middle term by bx plus bx. The value of c is, so here if x minus 1 is a factor, that means I can multiply a minus 1 by a positive 8 to get this minus 8. So this one becomes plus 8. So it's equal to 0. Okay, the first thing to do, I have to find the value of b. Okay, how do I find the value of b? Okay, we can do this. Okay, we can do this. Okay, let's just do this. You say this one times this one, and you multiply x with your bx. Okay, so you end up with dx squared. Okay, there are many ways of finding the value of b. Some can use long division, some can use inspection. There are many ways of killing a cat, but this is the one that I prefer. So this one times this one, you get bx squared. This one times this one, it becomes minus x squared. You equate it to the part that consists of x squared on on the cubic function, of which is minus 7x squared. So that means this one is equal to minus 7x squared. Okay, let's just, okay, here you see that you have x squared. That means we can factor out x squared. Okay, you're left with b minus 1 being equal to minus 7x squared. So you can divide both sides by x squared, or left hand side by x squared, or right hand side by x squared. So you're now left with b minus 1 equal to minus 7, meaning your b can be written as minus 7. You add what? You add 1, so b becomes minus 6. Okay, seems as if you are winning now. Okay, meaning you end up with x minus 1. Now you have x squared minus 6x, because you now know the value of b, plus 8 equal to what? Equal to 0. You know the first factor, x is equal to 1, or have x squared minus 6x plus 8 being equal to 0. So you now have to find the factors. How to find the factors? We want two factors with a different sign. When you multiply them, they give you 8. When you add them, they give you what? They give you 6. There is no other factors except minus 4 and minus 2. No, 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 no. This one should not be equal to, mistake. And minus 2 should all be equal to 0. So that means our x can be equal to 4. X also can be equal to 2. Okay, let us go back here. Let us go back. Let us go back. Let us go back. Okay, now I can see that there are 3 x-intercepts. The first one is where x equal to 0, of which is equal to 1 is this one, and the other one is 2, of which is this one, and the other one is 4, of which is this one. Yeah. So that means we take this one. So we now go back to the given cubic function formula or equation, which is h at x minus 7x squared plus 14x minus 8. If you can plug in 4 here, you will get 0. So meaning for C, the coordinates are 4 is to 0. 4 is to 0, since we know that C is the x-intercept. Okay, moving forward, here we are given the graph H is called, we are given that the graph of H is concave down for x less than k, but we don't know the k. We're required to calculate the value of k. How do we find that value of k? Okay, when we talk of concavity, what should come in mind? Something that should come in mind is a point of inflection. How do you get a point of inflection? You get a point of inflection by finding the second derivative, or you are differentiating the given function of a cubic function two times. So here we did differentiate it first time, and then we got what? We got this, of which is 3x squared minus 14x plus 14. So for us to find the point of inflection, we have to differentiate this one again for the second time. So we know that h prime of x is equal to 3x squared minus 14x plus 14. Okay, now we want to differentiate it for the second time. So get h double prime x, which will be this one, which is an exponent of x multiplied by the coefficient of x, of which is 3. It becomes 6x, and then you say 6 minus 2 minus 1, you get 1, and then here it will be minus 14. And we know that a gradient at a point of inflection is equal to 0, meaning here we'll be having 6x minus 14 being equal to 0. So meaning we have 6x being equal to 14. We divide both sides by 6. Okay? So when you divide both sides by 6, you get what? Here the value of x is equal to 7 over 3. 7 over 3. Okay. Here, what I know is that using the information given to me, okay, I can write my real line here. This is my real line. Okay. On my real line, what I know is that there exists this value of x, of which is 7 over 3. That is the point of the x, that is the x coordinate, or the x coordinate, the x intercept of what? Of the point of inflection. But what I want to know is where in my graph does the function becomes concave down. So when it's concave down, it's when it's set. It's like this. That one is concave down. Okay, but when it's concave up, it's when it's like this. This one is concave down, up. Concave up. Okay, so you see that my graph goes like this. It becomes concave down, and then at a point of inflection it changes and it becomes concave up. So I have to find values of x where my graph is concave down. So in this scenario, since we are given the diagram, concave down gives a negative value, a concave up give you what? A positive value. So whenever you plug the value, it's either less than this one or greater than this one. That's why you will see whether is at this point is it turning concave up or concave down. So if you can plug value, this is less than this one. Suppose we decide to plug 0. I normally prefer using natural numbers because when I'm working with the fraction or rational numbers, it becomes a bit annoying, but I can use 5 over 3. Let me use 5 over 3, or even 2, because 6 over 2 is 2, so let me use 2. Yeah. Let me use 2. Go to my calculator. We know that 2 is less than 7 over 3. Okay. Just go back here. I use this one. I'm not using the normal function, but I'm working with a second. I'm working with this one. So this one, I'm working with this one. I am working with this one. Yeah. working with a second differentiated function. Okay, so let me now go back to my calculator. So let me plug 2. If I say 6 times 2 minus 14, I know that 2 is less than 7 over 3. So if I get a negative number, that means where my x is less than 7 over 3, that's where my graph is concave down. It becomes minus 2, and minus 2 is a negative number. Okay, let me plug a value that is greater than 7 over 3. Let me plug 3. 3 is better than that one. So you get a positive number. So I can then conclude that on my real line, okay, when I plug in the values that are less than 7 over 3, I get negative numbers. When I plug values that are greater than this one, I get positive numbers. So meaning when my x is greater than this one, my graph is concave up, but when my x is less than this one, my graph is concave down. So I can write this: when my x is less than 7 over 3. That's where my graph is concave down. That makes the value of k to be equal to 7 over 3. So that's how I find the value of k. I think everything was clear. Looking forward to meet you on the second video where we'll be still continuing with cubic functions. Thank you.